All right, darlings, this is your help file for problem number 4 on page 132. In this example, we have a sailboat. So when some of you drew a free body diagram, which was great, but the problem was when you drew it like this and then showed force of gravity and then decided that this right here is the normal force, which is the force north of 390, that is not quite what the problem is about. If we had a box on the floor, perfect. Even if we have a boat, then we have the force of gravity definitely going down. So this would be force of gravity, and this would be the force buoyant. We haven't talked about that type of force, but that's something that a fluid, in this case water, applies to an object that is submerged to it to support its weight. That's how boats float. In our case, what will help is a point of view from kind of like the bird's eye. So, and then we would have right here the force of 390 going north and 180 going east. These are the two forces that are applied to our boat. And be careful, if you draw hypotenuse like this, it doesn't really represent the force. Remember, since we're adding these, I could redraw. And remember when we talked about forces, I told you that we can also have what is called a parallelogram. In this case, it's actually going to be a rectangle. If I complete and make a parallelogram or a rectangle in this case again, diagonal will be my hypotenuse in the redrawn triangle. So this red vector right here is what I'm after. So that would be our net force. And the reason why we cannot use this is because our forces are kind of in the perpendicular plane, the plane that is along with the water. So we wouldn't be able to show the forces appropriately. The rest is just adding two vectors that are perpendicular to each other. So using Pythagorean theorem, 390 squared plus 180 squared, root of that gives me 430 newtons. Now, that is just the magnitude of the force. We also need to know the direction. So again, if I look at this triangle right here, this is north and this is east. So if I take the negative tangent, or inverse tangent rather, and I go north over east, which will give me 390 over 180, since I'm going north over east, then my angle is going to be north of east. And I end up with 65.2, so I can just round it to 65 degrees north of east. But now, mind you, what they are really asking for is the acceleration, not just the net force. Well, Newton's second law shows us that acceleration is proportional to force and inversely proportional to mass. Vector sign here and vector sign here. Acceleration is in the direction of the net force. So therefore, I will take my 430, divide by the mass of the boat, which in the problem is announced as 270. So then I have 430 over 270. That gets me 1.6 meters per second squared, since I'm after acceleration, at the same direction. So 65 degrees north of east. And that is how you solve that problem number 4 on your homework for Newton's second law.